Hello AP Physics 1, it's Mr. Ng with a short lesson on angular quantities, namely what is a radian, what's rad. So in this lesson we're going to talk about what's a radian, right? Simply put, a radian is 57.3 degrees. And there is something very special about 57.3 degrees. The book gives you a little diagram, and this basically is 1 rad, meaning 57.3 degrees. And at 57.3 degrees, this radius, the radius of the circle, is going to be the same length as the arc length, as this little arc there. They're going to be the same size. That makes math later on way simpler. So again, a radian is special because it's a very special angle where the radius and the arc length are going to be the same. Or, if you remember your unit circle, 2 pi rad is 360 degrees. And for us, our most important equation, your angle in radians. So your rad is equal to that arc length divided by the radius. Or your arc length is equal to the radius of a circle times the angle in rads. So if you already took a bunch of math, this might be super simple for you. And if this is a little bit new for you, just get really familiar with it. We're going to invest a few days to just kind of get this basic down, because later on we're going to talk about torque, we're going to talk about angular momentum, and then finally a moment of inertia. So we got to know this basic math first. Okay, so let's apply the definition that we learned in the previous slide about what a rad is. A rad is 57.3 degrees, or a rad is, 2 pi radians is equal to 360 degrees. So a bike wheel rotates 4.5 revolutions. How many radians has it rotated? So let's stick with our main point here, right? Our main point that we learned was that 2 pi, this is a pi, rads is equal to 360 degrees, and that's basically 1 revolution, right? So let's do this old school dimensional analysis where our given is 4.50 revolutions. Let's change that into degrees. So for every 1 revolution, it's 360 degrees. And then we know that for every 2 pi radians, oops, let's put the 360 degrees on the bottom, right? Every 360 degrees is 2 pi radians. So all we got to do is multiply across. So the 360 degrees cancels. Get out of here, 360 degrees, right? And then it's just 4.5 times 2 pi, really, right? So 4.5 times 2 pi, and I get 28.3. This is 28.3 rads. Done. It's just the definition of a radian. A radian is, 2 pi radian is 360 degrees. In this example problem, we're going to go through the definition of a rad and that equation that we talked about, where theta in rads is equal to L over R. So let's go through the problem. A particular bird's eye can distinguish objects that subtend an angle. Subtend an angle means puts out a little angle from that radius, no smaller than about 3 times 10 to the negative 4 rads. A, how many degrees is this? And then B, how small an object can be distinguished when flying at a height of 100 meters. So let's start with A. How many degrees is this? Our given is 3 times 10 to the negative 4 rads. And if you remember, 1 rad is 57.3 degrees. So all I got to do is multiply that across. So 3 to the negative 4 times 57.3. and I got 0.0172 degrees. 0.0172 degrees. That is tiny. And then B, how small can this object be when the height is 100 meters? So if you look at the diagram, the height, right, the height here is basically our R, and then the little arc length, the actual length becomes our L, right? So if you recall, we know that theta is equal to L over R, and that L is equal to theta times R. I think this is the equation we should use. So RL is equal to our theta, and our theta is 3 times 10 to the negative 4 rads, right? Let's keep it in rads for a convenient unit, times our radius, which is 100 meters. So all we've got to do is multiply that across. 3 to the negative 4 times 100, and I got 0.03 meters. 0.03 meters, or that is basically 3 centimeters, right? Which is kind of like the size of that mouse. Done. So this problem is pretty easy. Number one, know the definition of a rad. 1 rad is equal to 57.3 degrees. And then number two, know this equation where the arc length is equal to the angle in rads times the radius. Good. In conclusion, what do you need to take out of this lesson? Number one, what in the world is a rad? A rad is 57.3 degrees. A rad is equal to the degree where L is equal to R, and a rad is, well, we know that 2 pi rads is 360 degrees. That's a rad. I don't know how else to explain that. The equation that you're going to use a lot in your homework problems is theta is equal to L over R, where theta is the degree in rads, L is the arc length, and then R is the radius, right? Or another way to write that, L is equal to theta times the radius. There you go. Thank you very much for watching. You guys have been doing a great job.